Okay, here we go. We're gonna do some boards go up, please. This is a little bit experimental. I'm doing it on my iPad and then posting it as a video. So we'll see how it goes this time. I might change some things around next time or change some things within this thing. But what I've done is I have 4 problems I'm gonna have you do, and then after I give you each problem, I'm gonna go and show you the full solution. Once I show you the solution, if you got that correct, then you can just kind of skip forward through the video until I come back and give the next problem. It'd be nice if I could tell you what time that's going to happen, but I don't really know how to do that because the times are going to change based on me adding things in. Anyway, this is your first problem. So you are going to do x prime equals ax, where a is 4, 2, -3, -1. I want the solution. We're not going to worry about the phase plots for now. So go ahead, pause, and get your solution. Okay, so I'm going to put my answer up in a moment, so make sure you paused. Okay, so one more thing I should say about all this. I am sort of notoriously bad at basic math. I can do a lot of calculus, but basic math haunts me, as many of you know. So pretty sure this one's correct. But as we move along, I might have some errors and things. So now what I'm going to do is walk through this. Remember, if you got this answer correct, then feel free to just skip forward a little bit in the video until I give the next problem. X prime equals ax with this. I find the characteristic equation. I do the trace, which is +3, and negate it, and then do the det. I get 2. That gives me this, which gives me a lambda equal 2 and a lambda equal 1. With lambda equal 2, I take 1, 1, because that zeros this row and this row. Lambda equal 1, I take 2, -3. That zeros makes this a 6 and this a -6. And the other way around down here. And they both zero out. So my solution to this thing is x equals c1 times 1 -1 e to the 2t plus c2 times 2 -3 e to the t. I'm going to give you some undetermined coefficients problems next. Actually, I will say that in a moment. Okay, so here we go. Hopefully you got that other one correct, or you see how to do it if you did not at first. So now we're going to do some undetermined coefficients. I'm going to add in a monkey or an external force or an input, whatever you want to call it, to this system of differential equations. So I've got x prime equals ax plus this. Okay, so I'm going to do this for this one problem, and that's all. I won't do it for the remainder of them. But I just want to talk about what this means, because it's been a while since we've talked about this together. I got x prime equals ax plus this. This is my a. The top line of this system would be x prime equals 4x plus 2y. That's the 4 and the 2, multiplied by the x vector, plus this 3. That would be one line. Line 2 would be y prime equals -3x minus y, that's these guys, plus the 2t. So anytime I add one of these pieces, it would just be tacked on to the equation if it was written out. And this is an equivalent way to write it, because this is a 2 tall vector, this is a 2 by 2 matrix, this is a 2 tall vector, this gives me a vector, and then everything adds. Anyway, so problem 2. Do undetermined coefficients on this system to figure out what your xp would be. So I want xp equals what? I will give you a moment to pause. If you have no idea how to do it, then maybe you just keep going and let me walk you through this one, and then you can try the other ones. And I'm going to go now. So, here we go. This is where I hope that I did this correctly. I know my process is right, it's just the details that Maybe if I mess something up, you can like leave a comment or something like that. Anyway, x prime equals ax plus this. So first thing I have to do is figure out what my xp is going to be. Okay, so here we go. This is the part where I hope that I did everything here correctly. You know, I could have messed up some basic math. The gist of what I've done is correct, at least, the process. Maybe leave a comment if I jack something up in here. Anyway, I got x prime equals ax plus this guy. I need to look at that guy and take all of the derivatives of it until it either goes away or goes to 0. That gives me a plus bt, and I got a 1's in the top and or 1's in the top subscript and 2's in the bottom. So I take a1 plus b1t and a2 plus b2t. So just for reference, say this 3 up here was a 0, right? I would do the exact same thing. Why is that? Because the 2t derives to something that's a constant, and this is a constant. So that's kind of taken care of in this, right? So you always got to take the biggest thing you have, derive it. You know, say you had like a t to the 5th instead of a 2t. You would have a massive numbers of a1, b1, c1, whatever. It would go on really long. I don't expect you to do that in class. Anyway, so that is my xp. Next thing I do is derive it. And then I fit it into this equation here. Here's my x prime. So that means that I'm going to take xp prime and put it in there. That's why the b1, b2 show up here, because that's the prime. I write my matrix A. Remember, we're using the same matrix A all the way through here. And then I write x. Well, what's x that I'm using? I'm using xp, so this guy right here slides in right there. And then I do plus the remaining part of the equation. From there, I got to do some matrix multiplication. I go across and down. This looks a little weird because this here looks like a square matrix, but it's not. It's a column vector, and the top entry is a1 plus b1t. So I go 4 times the top row, 4a1 plus 4b1t, that's 4 times that, plus 2 times the bottom row, 2a2 plus 2b2t. That is the top times this, right? Then I take the bottom row and multiply it the same way. So I do negative 3 times the top and negative 1 times the bottom. That gives me negative 3a1 minus 3b1t minus a2, that's negative 1, minus b1t. This guy stays the same, this guy stays the same. From there, I'm going to build, for me it's always easiest to build this into a matrix and then RREF it to figure out what the values are. I use my calculator to do that. So REF is a reducer echelon form, and it's like a technique from linear algebra that we use to solve systems. Anyway, so this to here is one spot that's like super error prone, in addition to the multiplication that we just did. What I like to do, I didn't cross things out here because I wanted you able to see this, but what I like to do is write in the rows. All right, so I'm looking at my equation 1 with the t's, right? So what I would do if this was my paper is I would have crossed that out when I put this 4 in, right? And then I would have looked at gotten the 2. The 2 is with the b2t, right? So I would have crossed that out. And then there's no, you may say, why is the 0 there? What I'm doing is I'm taking all of the A1s, A2s, moving them over to this side. Oh no, I made a tragic error. Okay. This is negative right here, and this is negative. All right. Okay, so I will explain the error that I made there, and then I've already fixed it here. And I will have to fix it in the rest of the ones that I'm doing later on, but that's okay. Anyway, so the deal here is that I got all these A's, right? A1, A2, B1, B2. And I got this one. I'm going to take this one and move it over to that side and leave all these guys here. Now, if I'm going to set up a system of equations, you should understand how these relate to systems of equations. Then this is a term, this 3, is the term that does not have any A1, A2, B2, any of these guys on them. So I have to take it and move it over to the other side. Hence why this is a negative 3. Same thing with the 2 on the T term. This gets popped over to the other side. So I hope you see that how all of these things correlate with everything in here. Well, maybe I'll talk about the equation 1 term, right? So I've got a 4A1, that's this. I've got a 2A2, that's this. And then you may say, where does this negative 1 come from? Well, that comes from this guy moving over to that side of the equation. Just like this guy becomes negative by moving it over to the other side. Anyway, so I do that. I do the same thing with the lower equation. I leave this on the right side. I do RREF, reduced row echelon form on this matrix. And I get these guys, a negative, and then this guy's positive, positive, negative. Then I get this for my XP. So the solution to this thing would be X equals XC plus XP, where XC is this guy right here. So that thing would get reused over and over again in the solution if I were to put different inputs, forces, monkeys on here. Anyway, so hopefully you go with that. I'm going to stop. I'm going to go and give you the next one, and then we'll work through that solution. Okay, here we go. Problem number 3. X prime equals AX plus, now I've got a input that is a sine function. So it would look like this. I want you to find XP. Little reminder, you have to take all the derivatives of the sine until it goes away or comes back. And you got to have it in the top and the bottom. So you should have 4 unknowns just like the last one. Go ahead, pause. Give it a shot. I'm going to move over to the answer in just a moment. Okay, here we go. You should have this guy. I have fixed it for this error that I made in all 3 of these problems. If you got that, great. You don't need to listen to my explanation. You're good to go. You can fast forward until we get to problem number 4. If you want to listen, listen. Okay, so here's this guy, same matrix A, same process. I got sines and cosines. I do need to have them at the top and the bottom. That's because this here intermixes x's and y's into x, and x's and y's into y prime. So x prime, sorry. So they're all intertwined, which means that if this is up here, they're going to show up in the bottom, and I got to deal with them appropriately. So here we go. Sines and cosines, A1s, A2s, B1, B2. Take the derivative, A1, A2 cosine, negative B1, B2 sine. Really hope I don't find an error. So then, same process. X prime is going to go on the prime side. XP itself is going to go right there. A is this, so I've got the prime, I've got X, I've got the matrix, and I've got this other part of the equation. So this line from here to here, all I did was multiply this matrix in. So the 4 gets multiplied by the A1, B1, 4A1 sine, 4B1 cosine. The 2 gets multiplied by the A2 sine, B2 cosine. 2a2 sine, 2b2 cosine. Negative 3 gets multiplied by the top. Negative 3a1 sine minus 3b1 cosine. The negative 1 gets multiplied by the bottom row. Minus a2 sine minus b2 cosine. From here, I'm doing the same work as in the last one. I have an equation 1 with sines and an equation 2 or equation 1 with cosines. So that's where I get these two lines, and this is equation 2 with sines and then cosines. So take a look. I'll do some crossing. 4a1 sine, that's this. 2a2 sine, that's this. And then this one comes from this term moving over to the other side. It becomes positive when I move it over. This guy goes negative when I move it over there. So I hope you see why all those guys are what they are. The 0 is there because if you look through, there's no b2 sine term. Same thing with the cosine. It's the remaining ones. Notice this one was positive on this side, so when I move it over, I get a negative 1. And the equation 2, sines and cosines, rip them out in the same way. There's a lot of patterns that you probably start seeing. Sometimes they'll be there, sometimes they won't. You'll see the next one that I give you is a little bit different. It seemed easier at first, but then it was tricky. Anyway, RREF that matrix, get your values, and then take those values and just attach them to this equation right here. So when I get A1 is negative 8/7, that goes here, here, and the rest of it there. Hopefully you're good with that. I will stop and then give you the next one. Okay, here we go. Problem number 4. Same matrix A, changing the input. The input is now e to the 4t in the top and e to the negative t in the bottom. So that would look like this. I want you to do the same thing we've done so far. Find xp. Think about it for a moment. Maybe pause, but come back before you do your solution. What's this going to give you? What's that going to give you? Same as the last two, you're going to have an A1, A2, B1, B2. So make sure you have that before you go all the way through. Going to go on to the solution in just a moment. Okay, here we go. Now, I will put a disclaimer out there. This one was a lot of keeping track of things mentally in my head, so there is a moderate likelihood that I did not do this correctly, and I apologize dearly for that, but it's the process that matters. So, I know that might sound lame. Anyway, this is what I got right there. Hopefully we agree. Crossing fingers. Yay. You can see I fixed my negatives. Let me walk through it. Let me walk through the process, really, like the thought process with everything. All right, so just like the other one had sines and cosines and everything was intermixed, right? I got an e to the 4t and e to the negative t. Well, what's nice about e to the 4t is it derives back to itself with the coefficient. Same thing with the e to the negative t. So the e to the 4t gives me these two terms. The e to the negative t gives me these two terms. You do need to have the a2 here on the 4t and the b1 here on the e to the t. Otherwise, you're going to get some kind of system that is unsolvable or has like free variables or something like that. All right, so do the derivative. Chain rule with that, chain rule with the negative there. Then these guys go in on the prime side, these guys go in here, matrix goes in, this part of the equation goes in. Do some matrix multiplication. 4a1b1, 4a1b1 with the correct exponents, 2a2b2 with the correct exponents, negative 3a1, boom, boom, yep, that looks correct, minus 3b1, minus a2, that looks correct to me. This guy stays there. Now this is where it's different from like here. Here we had these derivatives that like worked out nicely, and it was like, oh, this pattern where like the same thing happens. Well, on this one, my my derivatives, they derive to themselves. So that means that they mix in a way that's kind of annoying, honestly. You might start building it out, like you see the 4a1 here on this e to the 4t. And it also, like, I chose numbers that sort of had weird coincidences. So this, you might say, oh, there should be a 4 right there. Well, there's not. Why is that? Because this guy right here is on the other side. When I move it over, it subtracts out and it goes away. This guy, when it moves over with the B1, let's see, it gets added to there, which gives me, yes, good. So this gives me 5B1 on the e to the negative t equation, which is this one, which is that 5 there. The 2 is the 2. This 2 here comes from that 2 right there. This guy moves over to the other side of the equation and gives me a negative. Same thing with this down here. This 3a1, that remains the same, so that's negative 3. This guy right here, let's see, 3, oh, that's the next equation. So I got my e to the 4t. This one, I've got a2 e to the 4t. Well, here I've got 4 of them. So when I subtract that, I do get my negative 5. And then this guy is that guy. And then look here, it happened again. This thing, maybe that would happen every time. I don't think it does. I think it's just coincidence. This thing, this negative here, actually winds up canceling with this negative here when I add that to both sides. That's why I have a 0 there. And then I already talked about this. It gives me that. Reduced row echelon format, I get this. Hopefully you're good with this. I'm kind of experimenting with how to like do board work while we're all locked up in our homes for COVID-19. And I thought this would work well, but it was a lot of work on my end, and I don't think I have the capability to keep doing it this much. I'm going to try to experiment a little bit more, see if we can keep doing this. I want to keep as much of the class that works well as possible, and I want to keep you guys practicing, and I want to keep it so that you guys can look at solution sets. So I may wind up doing it in a different way, but hopefully you feel pretty good with this. We are going to move on next to an idea that is a different way to solve these types of equations. Totally different. It doesn't use any of the A1s, A2s. It's a straight-up formula. It's called variation of parameters. It's super cool. I actually prove variation of parameters. I will prove the formula for you using essentially this technique that we're doing right here. Anyway, thank you. I hope you all are well. I hope your families are well, your friends are well. And I hope you're still happy to be learning math. I'm happy to be talking about math. All right. Thanks, y'all. Bye.